Hi everybody, we're going to talk a little bit about solution concentration. Just a little reminder about what a solution is. First of all, a solution is something that's considered to be homogeneous. Secondarily, a solution is also a mixture. Remember, there are only two types of matter. You have pure substances and you have mixtures. Remember that a solute is the item that's in the lesser amount. It's generally also a solid, although not always, and it is the substance that is being dissolved, and it's being dissolved by the solvent, which is the substance that does the dissolving. And secondarily, the other way to think of a solvent as the item that is in the greater amount. Generally, it's water. We can also talk about solutions as if they were dilute versus concentrated. So you went through a little bit of this with your molarity activity, the POGIL one. And so this is qualitative data if we talk about it in this term. So we can talk about it being concentrate, we can talk about it being dilute. It may be that there's a visual difference in the color as something becomes more concentrated, and also the way that it appears. So one thing that you might look at is the viscosity of something, which is how thick the flow of an item is. So a concentrated solution contains large amounts of solutes, where a dilute solution contains smaller amounts of solute. There are a multitude of ways that we can measure quantitative data. So we can also measure concentration through a quantitative means, and there's a multitude of ways to do those calculations. We'll look briefly at percent by mass, which is a very common type of way to express medicated creams and the amount of solute they have within that cream. An example of a medicated cream could be hydrocortisone cream. There's over-the-counter strengths. There's also prescription strengths, which do a much greater job at dealing with intensive situations that require a cortisone cream. Percent by volume, so the rubbing alcohol in your home is a percent by volume concentration. Parts per million, parts per billion, that is very common to talk about water contaminants that are a part of the water system. And then there's molarity and molality, which would be the two that we will primarily focus on for this unit. They're very similar in nature, but they're also different in terms of what type of data we're using to solve for those two different types, molarity and molality. Let's look briefly at percent by mass. So there's a general formula for percent by mass. You take the mass of the solute, you divide it by the mass of the solution. Remember, there are two parts to our solution. If there were more than two parts, then you would deal with the total parts of that solution. But we take the mass of the solute, divide it by the mass of the solution, and then you multiply times 100. That's the other simple way of saying take the solute and divide it by the solute plus the mass of the solvent, multiplied by 100. Okay? So let's do a quick calculation with that. All right, so let's look at this particular problem and see what it's asking us to solve. A solution of sodium chloride is prepared by dissolving 5 grams of salt in 550 grams of water. What is the concentration of this solution in percent by mass? So we know that we have 5 grams of salt and we have 550 grams of water. It tells us that we're dissolving the 5 grams of salt, so that should be a signifier to us that the salt is the solute and that the water is the solvent. Secondarily, we know that because the salt is in the lesser amount. And the third way that we also know that is that water is the universal solvent. So we need our formula. And of course we have our given, which is 5 grams of salt. We know that we have our 550 grams of water. We've identified salt as the solute, and we've also decided that the water is the solvent. So our formula is to take the solute, divide it by the total mass of the solution, which the solution is made up of the solute and the solvent, and we're going to multiply that times 100. Oh goodness, I'm so sorry, y'all. I forgot that I had it set up two different ways for us to solve. Okay, so we're going to take our 5 grams And we're going to divide it by the 5 grams plus the 550 grams. So we're going to multiply that times 100 for a percent of 0.90% solution of salt water. What would I use something like that for? Sure, you don't really measure it out, but anytime that you have like a sore throat, a lot of times they'll tell you to gargle some salt water. All right, let's look briefly at molarity, and we're going to pick up in class with molarity calculations. But molarity is another way for us to express the concentration of a solution, and specifically mathematically. So the formal definition for molarity is the number of moles of solute dissolved per liter of solution. So our formula, can you guess our formula for that? It was a part of your POGIL activity. I would hope that you might pull from that something really important, the word moles and the word liter. Okay, so molarity, we use a capital M for our symbol. You've seen that multiple times throughout the year. I've briefly discussed what it means, but we've played around with 3 molar hydrochloric acid. You guys have used 6 molar hydrochloric acid, and all that is letting me know the concentration of that particular solution. There's a certain amount of that solute dissolved per liter of solution. And so when I read that, it's molar, 3 molar hydrochloric acid, 6 molar hydrochloric acid, 2 molar sodium chloride solution. And then our formula for that would be moles of solute divided by liters of the solution. Or in more simple terms, you could just look at it as moles per liter. All right, and we're going to pick up first thing in class with working out some calculations for molarity. See you tomorrow.